She does not do it. So here we go. Here we go. Okay, well, I don't know what to tell you, but we're gonna figure it out right now. Okay. All right. So hey, you know this. When I say inverse, you say switch. Switch. Oh my gosh, this is going terribly. Switch X and Y. You don't remember that? When I say inverse, you say switch X and Y. Before that happens, we have to save a student. So here we go. I don't want to say her name on the thing. Okay, so here we go. Passive aggressive note. You took my calculator away, so I can't do this question. This is happening right now. All right, so listen. Okay, here's your equation. We're going to zoom way in on it. Can you see that? All right. So, what number do you think I'm going to plug in first to see what this graph looks like? Even though it's already graphed over there, we need to know how to graph this by hand. So, what number would I plug in? -2. What's -2 plus 2? 0. What's 0 plus 3? 3. Input. Yeah. Input. Output. That's what that means. That's how you graph by hand. Then you go over to the graph and go to -2 comma 3 and you go and you make the dot. All right, now what do you do after that? Before and after you put in points. So what point would I put in next? K. K. Okay. So what do I put in next? -1. Fine. Or okay, I go that way. Wait. No, actually going up, I guess, would be that way. All right. What's -1 plus 2? What's -1 plus 2? 1 cubed. 1 plus 3. 4. And then you go over to the graph and go -1 comma 4. And you graph it. All right. And then what do you do? What's the other number you probably should plug in? We're gonna do 2 more. Okay. Okay. So what's -3 plus 2? What's -3 plus 2? -1. What's -1 cubed? No, negative times a negative times a negative. This is why you can't use your calculator. Okay, so what's -3 plus 2? Net -1. What's -1 plus 3? 2. Okay, and then that's why we get this point. But we need a couple more points to get this taking off behavior. So I'll plug in 0. By the way, what's 0 comma called, everybody? 3, 2, 1, go. Whoa, whoa, whoa. Y-intercept. Everyone should know that in this room. If you don't, there's the door. Okay, you're out. Okay, 0 plus 2 is 2. 2 cubed is 8. 8 plus 3 is 11. I have been doing this all year long, this whole input output to save you to graph anything. All right, all year long. Off the charts. Oh, I gotta breathe more. All right, and then -4. I'll just put this up here. Out of space, they should have given me 5 blanks. -4 plus 2 is -2. -2 cubed is -8. -8 plus 3 is -5. All kidding aside, if we are still not able to do this, you are severely and totally what? Behind. You are so far behind. You're like 5 years behind in math. I'm done with this. Okay. To still tell me you can't do this is a problem. So we're going to move on and be positive the rest of the way. Hopefully, you can function without a calculator from here on out. And we will definitely have no calculator stuff all year long because it's going to happen on the AP exam. So get together. When I do something in the homework where I'm not doing a calculator and I'm doing this mentally, you need to train yourself. Otherwise, disaster occurs. Okay, so function f has an inverse or is what's called invertible. Big word. Can everyone say invertible? Invertible. If each output value of f is mapped from an input value y. Great definition. I've always said this thing. All right. Good foiler, say it. Okay. Input, say it. Here comes another one. When I say inverse, you say just switch x and y. So let's do that together. When I say inverse, you say nothing over there, sitting there in a zone. Love it. Teaching in America. All right. So when I say inverse, you say switch. Whoop! Hello. There you go. Switch X and Y. I just love the non-interaction. All right. So I literally can take the inverse of this just by looking at this chart of values, and everyone say it. Switch X and Y. Okay, so 2 comma negative 3 becomes the new 3 comma negative 2, 4 comma negative 1, 11 comma 0, and then negative 5 comma negative 4. I should write that in my notes. Mrs. Cooper, I remember teaching with her in what was called pre-calculus honors. She didn't like that. She liked to say domain and range exchange. All right. So I'm going to do a little bit of, both of those things. But what's the domain? The domain is the X's and the range is the Y's. Okay. So I just think it's a practical thing for the students to remember how to find an inverse and what the relationship is next. So 2 comma negative 3, 1, 2, 3. 3 comma negative 2. And basically, I'm showing you how you find the inverse of a picture. Remember, input, output. I got it. Don't repeat me. Input, output could be a chart, could be a graph, or it's going to be equations, right? And that's 3 ways you can represent a function. All right, 11 comma 0, that's the one that's off the chart. I don't know if I did that justice, but we'll just make a guess. And negative 5, negative 4 does go right here. Okay, and then you're going to have a relationship known for a graph and its inverse. Maybe pick a third color for what is called the y equals x line. That's called the y equals 1x plus 0, y-intercept of 0, slope of 1, where the graph. Okay, what does this sound mean? What's that the sound for? Okay, it actually starts with an S, symmetry. It is a reflection. Oh, someone said reflection. So it is a reflection over the y equals x line, or it has symmetry with respect to the y equals x line. All right, I'm going to move on just to get this going a little bit faster. Okay, so some things to know about, they ask if it's going to be invertible or not. So first of all, a function is a function if it passes the vertical line test. This is if we're looking at a picture. Look at this original picture. Don't mark it like I am, but look, this is a function. How many times does each vertical line cross? How many times? Once. That means there are no repeating x's. But then the horizontal line test, yay, I love you. I missed you. All right. It's just something that happens all the time when the paper slides and ruins my life. All right. Sorry, my pen's going bad too. The horizontal line test actually proved that the function has an inverse that's a function. How many times did those horizontal lines cross the original graph? Once and only once. That means when I find the inverse, how many times are these vertical lines going to cross? Once. So the horizontal line test tells me that I have a function that's invertible, meaning its inverse is also a function. Okay? So vertical line test, horizontal line test. I saw a math 3er shake their head. They remember this. All right. So it is not a big deal. And I'm surprised they don't. Where would he have the y equals x? There it is. So the y equals x line is in that next paragraph, not quite yet. But that's what they mean. Are the following functions invertible? And I do have that thing in the way. There we go. So first of all, is this a function? Yes or no? Is that a function? 3, 2, 1, go. Yes, that's what the vertical line test tells me. Now, is it invertible? How many times do these cross as I run through these horizontal lines? Once and only once. All that guarantees is I don't have any repeating y's. So when I switch x and y, I won't have any repeating x's, which is the definition of what a function is. All right, but anyway, we're going to do the same old, same old. The best thing to do is get as many coordinates as possible so that we can switch x and y and still get the shape very close to the shape originally. So we'll take that point, get ones that are really hit spot on, that one, and then that one. We're going to take those 4 points. I don't think I have to do both of these. I think for purposes of time, we won't, but I am going to write these in green. And this is why I like this too, because -3, -1, people have to know coordinate plane and how to write a coordinate. -1, comma 0. Again, the door. If we don't know it's X, comma Y, that's the stuff that I see happening that should not be happening. This is really what's hurting most people. It's basic skills. It's not the pre-calculus. You want to complain to other people in the hallways. It's not. It's not. All right. And then I'm going to take this. So this is f of x. I'm going to cowboy this right to left. They usually probably would say, here's my original points. That's what f of x is. And then just for note purposes, here's what the inverse of f of x would look like. Well, I just take all these coordinates and switch them and then do the best I can to draw the new graph, getting all the features there. -1, 1, sorry, had to get my mind right there, and then -3, 2. And then I'm going to draw the y equals x line just to prove, say it. Well, I already did that part. Say it. Okay. All right. 0, comma, -1. -1, 1. Gonna be kind of tough. -3, 2. -3, 2 is up here. Okay. I guess I could have done one more point. Like, I'm just a little nervous here. So let's say like this is -2, comma, a quarter. All right. So then that means a quarter, comma, -2 would get me that shape right there. I wonder if I have a distorted picture there, because it is kind of like this. So this kind of goes like this. Kind of hard. And then I guess this is good enough. You got some curvature there. I'm trying to look at my coordinate plane. That looks pretty good. Actually, just a little nervous there. Making this, the loops and the curves look pretty nice. And then there's the y equals x line, and you can see that symmetry then without boring you to tears. All right. So I'm not going to do this next one, but I would, choose points. Okay, I'd choose this one, maybe this one, and then this one. And then if you have a little bit of a question about some of this curvature, maybe pick like one more, like 1 7/8, comma 2, then do 2, comma 1 7/8, just to see where that the curves end up being at. Okay, reasonable, pretty easy. When I say inverse, you say switch X and Y. Okay, now just a different thing here, and I've already talked about this. I'll put this in green. Okay, this means we can reflect the graph over the y equals x line to graph the inverse. All right, so that's what we were just basically doing, but it happens after you switch x and y, so it's all good. So the domain and range of the function and its inverse are swapped. And we are going to start talking about this. When I say inverse, you say switch x and y. That means the domain and the range are switched. So let's first talk about what f of x's domain and range is. So we'll go D. The domain is from -2 to 3, and that's it, including -2 and 3. So hopefully you can see those as brackets. And you really do want to make sure you have that. And then I'm going to actually add a thing down here talking about the domain and range of the inverse and show you a relationship already. And then the range is whatever the y's are. So the y's are, got to look here, from -3 to 4 are covered. And they are included because you don't have those open dots that you see sometimes. So the range is from -3 to 4. Shouldn't have to ask anyone this. This is all stuff you should have known walking in here in August. The ability to do that. Okay, well, I'm going to go ahead and do the switch X and Y thing. And we're just going to do it not by writing it out. So that point's -2, -3. So the new point is -3, comma -2. All right. And then where's another good point? Here we go. I got a good one here. 1, comma -2. So now that's -2, comma 1. All right. Oh, so close. It's almost at 2 comma 0. So it's like 1.9 comma 0. So that's 0 comma 1.9. So you still want to do that. Even though it's not perfect, this will help give you the curvature you need. And then I think the last point's good because it kind of just kind of almost gets pretty flat there. 3 comma 4 is now 4 comma 1 2 3. All right, and then you got this, and it was pretty smooth curved like this. And by the way, function originally was 1-to-1, and I know I kind of threw that out there real quick, but when it passes the horizontal line test, we've already talked about that. That means the function has no repeating y's, which is said to be a 1-to-1 function. But then that means it's invertible. All right, so you do want to check, do you have a function, vertical line test? Is it invertible, horizontal line test? All right, but it is. Look at the green, it passes the vertical line test, so you're good. All right, well, they talk about this, and then what I'm going to do is do the inverse of f of x. So what is the minimum value now of this? These switched. The minimum of the original was -3. Well, now the minimum for the new function is -2. All right, and it's located at -3 at x equals -3. Remember how we worded that back in the day, both in chapter PR and then definitely in when we had rational functions and all the cubics and quartics and blah blah blah. And then what's the maximum of this? It is 3 located at x equals 4. But a much better question is for the inverse of f of x, notice the domain and range. The domain, and I want you to do this. I want you to write this and draw an arrow and connect them. The domain of this is -3 to 4, which is exactly what the range, maybe we could do highlighting, the range of the original function is. When I say inverse, you say, well, let's do Cooper's thing, domain in range. Anyone? Exchange. Okay, so that's exactly what happens. And you're going to need to know that and know that connection by definition, because sometimes it's not so obvious. You have to know that this happens. And then the range, well, when I look at the picture, it goes from -2 to 3. All right, it's all those range values that are covered. Back. So didn't want to cover that too quick for those that are severely and totally anyone behind, because we're supposed to know this. This is not like, oh, I didn't know that. Well, been on your phone too long or something. I don't know. Not doing your homework legitimately, sipping those triple lattes instead of paying attention in class. Double espresso. I'm sorry. Call the lawyers. All right. You got it wrong, Mr. Samuelis. All right. Okay, now this is why I like when I say inverse, you say switch X and Y. So now what we can do, this is from the bell work in the beginning. I found like 5 coordinates from the original. I switched them and then made the picture. But to literally do this, you literally switch X and Y and then resolve. So now comes some algebra, and I missed it. We haven't had algebra in quite a while, and it's going to get a little bit rough on the bottom. So we got some tougher ones here coming up, and we'll see how you do. All right. But first thing I want to do is, and I don't have this in here, we should be saying what the domain and range is of the original, and then talk about the domain and range of the new. But for domain of this, for cubes, you can throw in any number for x, cube it, add 3, blah, 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 blah. There is no problems. And then for cubics, there is no problem with outputs that you get. I mean, let's look at our picture of this up here. If you missed what I just said there, that is this picture in red. There's the equation. We input outputted, and we know if we keep going, 1 plus 2 cubed is 3, 3 cubed is 27, plus 3, 30. This starts getting, taken off immensely. So the range is covered forever as well. So again, input output can tell you those things. All right. Let's literally find the inverse. By the way, this is y, all right? We should know f of x equals y, or there's the door, and then literally switch x and y. Literally do it. And then re-solve for y. Now come your skills. Now comes the house of cards. Do we know how to do basic solving? Have we been a photomather? Have we been copying our friends' homework? Whatever. What do I do first? Subtract what? 3. And we're going to do equation solving 101. We're going to write all the steps because we haven't done this in a while, I feel like. Or I feel like it's been a little bit light algebraically as we've really tried to do the AP thing. And then what do? Do I subtract 2? Am I allowed to subtract 2, yes or no? And those that, you better be paying attention because those that do, that should not be happening at this point. You got to free this from the cube, from the grouping, or, the grouping parenthesis, or the symbol, the mathematics that is going on with that set of parentheses. So not free. So how do I undo a cube? What do I have to do to both sides? Anyone? Cube root. I believe we've had this before. And by the way, when I cube root both sides, is it plus minus? Yes or no? No, it's only when I square root or fourth root or sixth root or, I could keep going. Even rooting only creates a plus minus. We're going to talk about that in the very next one. X minus 3, and then the last thing we can do is subtract 2. So I'm just going to do this. We're high level, and then I want to rewrite this as the inverse of f of x. Got a little sloppy with my work here because I want to do the domain and range, but it really ain't no thing. Anyone? Chicken wing. I guess I haven't said that a lot this year. Not trained properly. All right, I wanted to move that over there because, and then the computer wanted to mess with me there. The domain of this, can I cube root a negative? What's the cube root of -8, for instance? Input, say it. What? Input, say it. If I were going to graph this, as a matter of fact, I might look up at my graph. If I plugged in -5, what's -5 minus 3? What's the cube root of -8? -2. -2 minus 2 is what? -4. I bet you see -5, -4 is a coordinate up here. Well, I'll be, all right? And that's why that is what it is. That's why we graphed this already and should know input, say it. Output. Rah! Happens every day in my life. It's all real numbers and all real numbers. So this doesn't really show up very well because the domain and range are both all real numbers, but I am going to highlight it again. The domain of the original ends up being the range of the inverse. The range of the original ends up being the domain of the inverse, but they're both the same. Okay, so the highlighting might be smart to do because now, Houston, we have that's from NASA, Apollo 13. Okay, we, for the first time in forever, have a non-one-to-one function when we're talking about inverses. Mathematicians cannot stand this. And I hope you math 3ers saw this last year. You math 2ers, you have to jump on board. This is why you took the plunge into this class. You chose. All right, input, say it. First one I'm going to plug in is 0. What's 0 squared? 0 times a half. 0 plus 2. 0 comma 2. 1, 2. Probably should have done a higher, or put this a little bit lower in the x-axis, way lower, because we're going to be above the x-axis. You know what? I'm going to make my life easier and plug in 2. 2 squared is what? 2 squared is what? 4. What's half of 4? 2. What's 2 plus 2? 4. And then we should know that what kind of picture do we get for x squared? If you don't, there's the door, because this is math probably 1, probably math 2, probably math 3. I didn't take math 3. And chapter PR. And then we actually did it again in the chapter 1 for AP, graphing parabolas. This is a parabola. Why? Because when I square -2, I also get 4. Half of 4 is 2. 2 plus 2 is 4. Here's the problem. This means the function in their terms is not invertible unless I do something which is called restrict the domain. So we are going to restrict the domain. So the domain of a function can be restricted to make the function invertible. You have a choice. Okay, so first of all, vertical line test, pass, 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 pass. It's a function, but fail. It's not one-to-one because a horizontal line hits twice. That means when I find the inverse, it actually literally would be a parabola going right-left, and then it would fail the vertical line test. Remember, for some reason, mathematicians love functions, and they hate non-functions. So therefore, they want everything to be a function, one-to-one inputs and outputs. So here's all you got to do. You could either eliminate this part of the graph, or that's weird how that happened. That was awesome, actually. I actually enjoyed that. Or you can eliminate this part of the graph. You actually have a choice. Usually people go to the right and they keep the right side. So what we're going to do is eliminate this part of the graph. How do you just eliminate that? Well, you restrict the domain. Input, say it. We say we are going to ignore these inputs and say the domain of our original is only from 0 to infinity, not all real numbers. Then it destroys that part of the graph. It limits what I input, so therefore it limits my outputs. And therefore I won't get those repeating outputs. That really cannot be said any better why we do this. The range actually, what a bragger, 2 to infinity would still be the output values. Okay, now when I take and find the inverse of this, sure, I switch x and y. We know that's y. So now this is x equals 1/2 y squared plus 2. Here's where we're going to get what we have to stop, what we can't do mathematically. First of all, subtract 2. So it's x minus 2 equals half y squared. By the way, people are doing this out of order as well. What do I do first? Multiply by 2. And by the way, it's multiply by 2. Don't divide by a half because people can't do that because of fractions. But when you divide by a half, it's the same thing as multiplying by 2. Do I multiply by 2 or do I square root first? Which one do I do? No, I heard a half and half there. And that's what the problem is. You can't square root now because then you're square rooting the half. And now you're creating an irrational number over here. And that's unclean and not good. So we need to multiply by 2. All right. And then you could distribute if you wanted, or just leave it like that, I guess. Y squared equals. There's a value to leaving it like this because we could talk about what these things are now, some tougher things from the past. Then how do I get rid of a squared? I already said it. 3, 2, 1, go. Square root. But when you square root both sides of an equation, what are you supposed to do? You're supposed to put plus or minus. And I'm going to put it here first, but then I'm going to destroy part of it because this is the negative output values. These are two graphs. If I put them on my y equals screen, you get the classic square root graph, just this part, but then the negative outputs give me this part. Put them together, you have that parabola that goes right left. That's a failure of the vertical line test. Let's do it right now then. Because of my restrictions, the domain of this new function, by the way, I want to call it what it is. It's the inverse of f of x. All right, the domain is the range of the original. So I'm only allowed to plug in from 2 to infinity. Well, that actually was true no matter what, because 2 minus 2 is 0. If I plugged in anything else, then I would then it would be an I number. But it's really the range. I don't know why I put x, because x is what the domain is. And then the range is the domain of the original. This is the big deal. This makes sure I only have positive outputs, so you're outs. So go ahead and try to make that look like a different color or something like that. You have to cross out that negative outputs because you have to keep the inverse a function. So that's how come this happened. So that's how come this happened, because this happened right here. And I'm going to color that in green. That's the big deal. The range of the new has to come from the domain of the original, which was restricted to keep the function 1 to 1. All right, so we're probably only going to do this on x squareds, this whole idea. It could happen in some other functions that we won't worry about too much. All right, got a couple more things to do. I'm just going to go ahead and do them real fast. When I say inverse, you say switch x and y. That'll probably really limit the homework that you see on your paper, but some of it's pretty easy. I'm really worried about 6 and 7. So I'll probably stop at 6 looking at our time. Plus, it's a Monday, and we do have 2 days for this. So probably wait for the harder ones here. But before I continue, here's the domain of this. The domain of this, again, this is review, and it kills me that we forget so many things because I worry about what you're doing when you're doing your homework, if we're really doing it legitimately or not. But what can't I plug in, or what can I plug in? We're running out of time. Can I plug in 3, yes or no? Yes. What's 3 minus 3? It's actually the first point I should plug in. And then what's the square root of 0? 0 plus 2 is what? And I've never written it because I don't think I have to. I should not have to. But then when I plug in -4, I'm sorry, not -4, 2, what's 2 minus 3? What's the square root of a -1? I. It just doesn't graph in a real coordinate plane. So therefore, the graph stops at 3 comma. All right, so 3 is the initial good value. And then go ahead. And then it goes off to infinity. I can plug in 4, of course, 5, 6, 7, 8. Who do we appreciate? 9, 10, 11. I just wanted one that works. 9. How do I get 9? I can't think right now. 12. I can plug in 12. 12 minus 3 is 9. Square root of 9 is 3. 3 plus 2 is 5. So you get an output value for that. But then what's the range? Well, you should know that this graph, input, output, 3, 2, 1, 2, 3, 2, just real quick is this. And then when I plug in 4, 4 minus 3 is 1, square root of 1, 1, and then I get a 3. You should know from our previous graph that that's that classic half parabola, right? Which I did talk about even in the last one, why if I had the plus and the minus part would be this bottom half, and then that wouldn't be a function. Again, it has nothing to do with this question, nothing. Just talking about this last one, why I crushed the minus part of the plus minus there. All right. Such an annoying feature. I do have to erase this though, so hopefully I had room over to the right to just draw this sketch. But the reason I drew that is when I plugged in 3 for x, I get 2 for y. That is the first output, and the outputs increase forever after that. So that's the range. So guess what? I could already tell you what the domain of the inverse is. It's the range of the original. So the domain will be 2 to infinity, guaranteed. What that does is it restricts. I'm going to leave that picture there because actually this is pretty quick on the inverse situation. X equals, now I'm doing the inverse, y minus 3 plus 2. Subtract 2. I do like the y's over on this side, so I'm going to also flip-flop. Subtract 2. Square. Now, what do I have? I have a parabola, but not a full one. A parabola that by default, the domain is restricted because of where it came from. So I will only have half of this parabola, from our previous thing. And by the way, when you square both sides, it's not plus minus. It's when you square roots. All right. And then I'm going to turn this into inverse notation and then add 3. And then I'm going to leave it like this because this is nice format. This is the vertex form of a parabola. So the vertex of this would be 2, 3, 1, 2, 1, 2, 3. Sha-na-na-na-na-na. Na-na-na-na-na. That's where they have symmetric points there. And then when I plug in 3 minus 2 is 1 squared is 1. 1 plus 3 is 4. Okay, so I plugged in 2. No, I plugged in 2 already. 3, and I got 4. I feel like this is 4, 3. Yeah, 3, 4. And then you kind of get this. All right. And then you could see that if I drew the y equals x line through there, you'd see that symmetry there. But you don't have to really know that on this one. It didn't say anything about graphing. I just wanted to tie some points together. But also tell you that you only get to graph half of this parabola because of the range of the original being the domain of the new. And you got to count for it. All right. Now, this is going to be sad if you forget this. And it is 25, 10 minutes. I don't want to go all the way to the bell. Believe me, when you go to college, though, you will go all the way to the bell. But you know what's great if you don't go all the way to the bell? What did I tell you the professor would say? Well, I'm done, so get out. And he'd kick you out. And then you'd be done early. All right. Used to love that. All right. But anyway, what's the domain of the original? Oh, boy. Here we go. Can we remember this? All right. We had like a month of doing this. All right. This is where I get sad. I lose a little, I don't know, years in my life. Oh, someone just went, oh. What can't you plug in for X? Because that's naughty in these kind of situations. 3, 2, 1, go. Yeah! -6. So the domain this is annoying. It's all real numbers, but -6. And I don't have enough room for that. So I had to do 6 to infinity. And then what's the range? Here's what's going to kill me, but I'll give you a hint. The numerator's degree is 0, and the denominator's degree is 1. Where is the horizontal asymptote then? Y equals what? 3, 2, 1, go. 0, 1 student. Oof. All right. Y equals 0 is that rule. Or input, say it. You will never get 0 as an output, no matter what you input. That is the whole point of why we had these horizontal asymptotes. So guess what? Guess what the domain of the inverse is going to be? That. It'll be everything but 0. All right. And I'm not reteaching that. All right. That's stuff that we had to remember from back in the day. That's why I'm going to hold off on 7. So I really feel like we have to revisit that because it didn't go very well in that chapter. Just the flat out memorization of those rules for rational functions, which we spend so much time on. So much time. But when I say inverse, you say, this isn't actually that bad. This is y, so now it's x. This is x, so now it's y. Probably didn't do very well on my spacing here. And then what should I do first? Well, I think the fastest thing to do would be cross anyone, multiply 3 equals x times y plus 6. And I really don't think you should distribute that x. The whole idea is to get y by itself. So what should I do next to get y by itself? Should I subtract 6 or divide by x? 3, 2, 1, go. Divide by x. And then that really frees this up. And then that makes this really easy. Why I'm going to stop here is the next one's not so easy. We do have some major algebra to do, and I think this is a good place to stop. And then subtract 6 and then name it as a function's inverse. I don't know if it was called f of x up here. Yeah, it is. Okay. And I'm going to subtract 6 and I'm going to leave it. And then sure enough, darn tootin', what can you not plug in for x? And the answer is you can't plug in 0 because it'd be 3 over 0, which is undefined. Now, the range of this is actually in, oh, it's right there. Nice. What am I doing? All right. And then I didn't do this on this one. So the domain of this one is the range of this one. So this is 3 to infinity. My bad, dogs. Okay, I got it. Roof. And then look at this. This is the classic. You probably forget this, but this is the shifted version of a rational function. So this is where the horizontal asymptote is. It's at y equals -6. That's why the range cannot be -6. All right. And then I'm going to highlight that one more time. Highlight domain of this is the range of that. Okay, I think you're good. Let's go to this. I think you're good on 1 through 6, 7, 8, probably 1 through 8. You should be able to get started on. And then actually these are probably not that bad, but I could talk about those tomorrow. Really not that bad of notation. And you actually really should be able to do these. Okay, and I'm just telling you, it's going to be kind of a 2-day assignment, but I already did that. How do I find the graph's inverse? I just pick a couple points, and when I say inverse, you say switch X and Y and make a picture. So you should be able to do that. These you could hold off on. These will take like 1 second each. And then I would say everything up to 1 through 8, you're doable here. You could do those or not. Those are probably classic test examples. So they're probably not too bad, but all right.